And welcome, Mindsetters, to this session of Learn Extra Live. Here we're doing grade 10 maths. Hope you guys are ready. You've got your pens, pads out, and you're going to make some notes. I'm Ty, and I have Iti here with me. Iti, what are we doing today?
Hi, Ty. Today we're doing measurements, basically.
Okay.
Yeah, our focus is going to be more of, areas, how to measure an area and all that.
Oh, okay, cool,
Yeah.
cool. That sounds interesting. All right, so Iti, while you make your way to the board, Mindsetters, you know the drill. You need to get on the page, get chatting to me. Let me know what you guys are thinking. Hope you guys are loving the new art. By the way, just want to let you know, so you know, this artwork was done by Indiana, and she always loves doing her design thing. I also design. But anyway, besides that, we're here, we're doing maths. So make sure you guys get on the page and get chatting to me, www.facebook.com/learn extra. And by the way, I want to send a quick shout out to Liberty. And we're going to be giving out a lot more new stuff. We're going to be giving out Casio calculators and a labeler. So make sure you guys stay tuned. But for now, I'm going to hand you over to Iti. Iti, take it away.
Thank you, Ty. Greetings to our viewers out there. Yes, I said we're going to do measurements today. And, we talked about numbers being used to measure and to count, the quantities. Now, if you think about what kind of things we can measure, it's typically the area. You can measure the length, the height. You can measure time. You can measure the angle. There are many things around you that you can measure, right? If we are going to focus on area, for instance, the units for measuring area is going to be, we're going to pick on a few units that at least we can perceive. They are at a level where we can see how big that is. So typically, we could take the area and use units of millimeters by millimeter, which becomes millimeter square, and that we can perceive. 1 millimeter square, or we could look at 1 meter square, or we could look at a centimeter square, or a kilometer square. So at least something that we can perceive and we can measure. All right. So we're going to look at these areas as either flat areas or curved, areas. You've got curved surface around us all over. Like this TV, this screen behind me is basically a flat surface. If I wanted to measure the area of this screen, I would have to look at little square blocks that I can add up to the whole area. So essentially what I've been saying now is suggesting that there is a simple area and there is a compound area. So a compound area is when to get an area, I'm basically going to take several shapes and combine them to get one full surface. All right. So yes, I said here I'm going to look at flat surfaces that I'll add up to make up the total surface area of solids, for instance. Okay. And if I look at just the flat surfaces first, starting with a triangle, the area of a triangle is basically, let's start with a triangle. A triangle, its area is always going to be, if this is the base and that is the height of this triangle, it's simply going to be half times the base times the height. This is just to quickly recap because I'm sure some of you know this formula. And I could quickly look at a square just to relate it quickly to a triangle. If I look at a square, we always say length times length. So remember, a square has got all those sides, all those angles equal to that. So the area of a square becomes length times length. Now, I want to relate this to a triangle. I'm saying this is a simple area, for instance. I mentioned simple area earlier on. So this is a simple area where we're looking at it as the basic building block of any area. Now, if I look at a triangle, I can see it as a compound, area. What do I mean? If I use a different pen there, I can illustrate that like that. Imagine that that block is extended like that and like that. So what do you end up with? With a rectangle. Of course, I didn't mention the rectangle, area of a rectangle. If I can quickly write that down. If this is the length and that is the breadth, area of a rectangle becomes, buy some more space there. Area of a rectangle becomes length times breadth. But notice what happens now if I just look at a triangle. If I look at a triangle and I extend these pieces of areas there, let me just shade them. Suddenly what you can realize is that you have got a combination of, the sort of the sum of two rectangles. If you add those two rectangles, you'll basically be taking b times h. If this is h, of course, h is the same throughout here. You've got base times height. That is basically the same as in this case where you've got the length times the breadth. So if you then say a diagonal of a rectangle bisects the area of a rectangle, then you will agree with me that this area here will be equal to that area. So you've cut it into two halves, and the same applies to the other side of this dividing line. If you look at it like that, you will not be surprised, therefore, that if we took the full area and then divided it into two, it will basically represent the green part of this area. So now, that's why we say for a triangle, you can actually look at this thing as a compound area. You know, it comes from combining, some areas. Either you're adding them up, or you're subtracting one from the other, or you're halving one or doubling the other. All right. So that is just the area of a triangle illustrated, in relation to these two. All right. Another one we can look at, of course, we have already looked at the rectangle in that case. There are other quadrilaterals that you could be looking at. Okay, in this case, we have looked at a square as a flat surface. We've looked at a rectangle as a flat surface, and how they help us build, the case for a triangle. Other polygons could include a pentagon or a hexagon as a flat shape. All right. So if you are given dimensions, for instance, of a, okay, let's take, you could also have a circle. I think I wanted to move to a circle in this case. Okay. So the area of a circle, for instance, you could treat that as a compound area in the sense that if you have a circle, essentially the small triangles that you could add up going all the way around, they will all have a height called the radius by approximation. So now you will then add up all those triangles until you end up with, if this angles, for instance, were 1 degree here, so you'd basically be, you could add them up all up to 360 degrees, a full revolution. And if you add all those triangles up, they eventually give you the area of the full circle. Okay, I don't have to, to go through the whole proof, but I can tell you that the area of a circle eventually becomes pi times radius squared. All right, and the quantity pi is of interest here. It's actually about 3.141, so on. Pi is equal to that much. As you can see, it's approximately 3 times, this factor says 3 times. So all you're saying is, if you took, okay, another thing to remember in all of these areas is the perimeter. If you were to work out the perimeter of a circle, you'd end up with pi times diameter. So that is suggesting that this is approximately 3 times your diameter. So all you're saying is, if you were to lay out a diameter, remember, is actually twice your radius. If you were to lay out that, if it was just a string, if you were to lay out a string of length d around this circle, it would fit exactly 3 times, almost 3 times, well, slightly more than that. 1, 2, and 3 times. Just erase that. Okay, so it would go about 3 times and a small fraction, which is the 0.141 there. So some of these parameters you need to be aware of, especially when we get to solids, because we are going to have to slit boxes and all these other solids so that we can lay them out, and knowing how to go around the perimeter is very important. All right, so that's the area of a circle there. So those 3 flat areas we are going to use, especially when we build the case for surfaces on solids. All right. If I can move back to, let's see. So yes, we've dealt with the circle, the area of a circle. We've done with the area of a rectangle, of a square, and a triangle. All right. So let us go into solids now. And in particular, we are going to look at solids which are made up, of flat surfaces. And, we'll move into curved surface only toward the end if there is time. All right. So if you look at solids, some of the solids that you have to remember is the pyramid, the prism, and if we get time, we'll get to the sphere. All right. So with the pyramid, some of you have been to Cairo in Egypt, you've seen pictures. If you haven't been there, a pyramid looks like that. In this case, we say the base area of that pyramid is a triangle. So we're talking about a triangular. Hang on, I actually jumped to, I needed to move to a pyramid. Okay, let's go prism. Talking about a pyramid I wanted to talk about a pyramid. So that's where I wanted to be, a pyramid. Right, so look at, here we're going to emphasize what you call the base area, and with objects that are standing up. In this case, your pyramid has got a height up to there. Now, let's give dimensions to this. If we have, for instance, in this case, a perpendicular distance at the bottom, at the floor, of, let's say, 5, and that side of that base triangle, let's say it's also equal to, let's say, 7 units. And then it means the base area. Okay, we said we want to split this and actually see different sections of that make up the whole area. Then this one, let's give it a dimension. It's better to actually isolate these things. So the triangle that I was touching there, let's say it's got that slanting height of 7 and a base of 8 there. All right, that means you've got 8 there. And the other one, we could give it another area. Let's isolate it. This is another way to quickly get these things right, is to isolate them. If this was A, let me name it, that helps. A, B, C, D. So what I have here is triangle A, C, D, with the slanting height of that and a base of that. Okay, so here we'll have triangle A, B, C. The dimensions, let's pick on it, and I'm not going to be very accurate here. I'm just going to pick on a number that is less than 8 and 7. Okay, and that is a 4. Over there, I'm going to choose a height, a slanting height. Notice that I'm picking on slanting heights here. So in this case, I'll say 7 as well. All right. Then how many areas do we see? So you can see ABC as a triangle that you can see from this direction. And the other one you can see is this one, which is ACD, but right at the back, which you cannot see. If you have a house in front of you, some of the walls you will see, but some of them you'll have to go around the house to be able to see the rectangles that form, a house. All right. Let me just list this one quickly. That's obviously A there, and B, and D, and finally the one in the middle that I've shaded. Okay, let's take a quick break, then I'll proceed from there.
All right.
All right.
So on that note, mindsetters, make sure you get on the page. Let me know what you guys are thinking. If you're lost in, if you need help, post. Because yes, here's the stuff I was talking about earlier. I know I kind of magically appeared with them. But anyway, Casio calculator and the labeler. Make sure you get posting on the page. The best posts get to win this. But on that note, we'll see you after this break. Cheers. Welcome back, mindsetters. Hope you had a nice little break there. You went and did whatever you had to do, but you're now back. You're ready. You're here to make notes. But I want to make sure that you guys remember that, yes, I have this awesome Casio calculator and the labeler to give away. So I need you guys to get posting. I'm already seeing a couple of people there. I want to say shout out Pleasure, Filwe, Tuso, Lucinda. I'm seeing all your posts. Thank you guys for posting, you regulars. But on that note, this is where I hand over to Mr. E.T. E.T., take it away.
Thank you. Let's proceed from where we left. And yes, we're still dealing with the pyramid. I've got how many parts? That's 1, 2, 3, 4 triangles that I can add up to make up the whole surface area of that pyramid. So in other words, if I had an object that is in that shape and I wanted to paint it on the outside, I would actually have to work out, that surface area, by breaking it down like that. And you've seen sometimes this area would have been presented as, as a net. If you have heard about a net as well. So they would lay this out so that this is B and that is C, but when you stretch it out, when you cut it right at the top there, if you open it here and cut along those lines, you can actually fold that triangle until it lies on the ground and the top is A. And for the other side, that triangle would be A, B, D, therefore it would actually sit somewhere there, and that is D, that is B. Okay, and finally you would have triangle ACD. That is A there. Oh, sorry, that is A over there. Okay, the tip is A. So again, now you can actually clearly see if you can be able to do it like that, then that's much better because you can see those areas isolated, and you can actually add them up. Remember, the area of a triangle is now half the base times the height, and you would have to add each of them. For each of this triangle, you'll have to work out that area, that, and add them up to get the total surface area on that pyramid. And I think that was one of the questions earlier on, as to
yes,
what is the total surface area, what is the surface area. So it depends on how much surface you are given. If I said to you, you're going to paint the house all the way around, or you're going to paint one roof. So, one room, obviously it depends on, if I want to know how much paint I'm going to use, I'm going to just look at that section which I'm going to paint. and leave out the other one which I'm not going to paint. But if they say you're going to paint all of it, I will then have to find the total surface area and estimate the paint that I'm going to use to cover that area. All right, so I think that's just the basics on how to lay out a pyramid. And this particular one was a triangular base pyramid. You could also have a square base pyramid. So all it means is that the base area is doing a count of how many triangles will meet at one point at the top. If you've got a four-sided area at the bottom, then you're going to add that area to the four slanting areas that go to the to the tip of that pyramid. Okay, so if you had a square pyramid, let me just represent it quickly there, say like that. If that was your square pyramid, you would lay it out such that there is a square in the middle and there are the four triangles that you can fold over, and their tips will come to a common point. Okay, so that's what really a square pyramid would look like if you lay it out. This is also called a net. You hear them talk about a net, and this is what you do. So that would be area number 1. You add it to 2, 3, area number 4. There are 5 areas that need to be added up in that case. All right, square base pyramid, you treat it the same way. You know how to find the area of a square. You know how to find the area of a triangle. So you just apply those formulas. All right, that's that one. And you could have it as a rectangular base as well. If it's a rectangular base, same story. It's just that the length and the breadth won't be equal. They won't be equal. That's the kind of net that you're going to get. With this as the base of your prism. Of your pyramid. Keep mixing the prism and the pyramid here. All right. So that would then be broken into how many areas? 1, 2, 3, 4, 5. So you can almost always say that if you have a quadrilateral as a base area, you are definitely going to have 5 areas to add up to get the total surface area. And if it's a triangle, you're going to have 4 surface areas to add up. And someone is already saying, what if you have got a pentagon? A pentagon, it's a 5-sided polygon. If you have that as the base area, so if you count the sides of a pentagon, you're going to have 5 sides, which then tell you you're going to have 5 triangles merging right at the top, and you add the base area. So then you'll have 6 areas to add up. All right. That is covering the pyramids, I think. Of course, we can talk about a cone here. If you think of a cone, it is basically some kind of pyramid with the base area that has got infinite number of sides, which is called a circle. So what am I saying? If I have a circle like that, so I could look at this circle as small lines that described a circle. And for each of those, I could see a triangle that I have, all those triangles that I have to add up to make up the total surface area. So that, it's more like the limiting end of the pyramids, where you've got an infinite number of sides. For your base area. Okay, so for a circular base pyramid, let's see. So what you're going to have, I think it's going to be base area, Again, it's going to be the base area. What is the base area? Pi radius squared, and you're going to add the area of that curved section, and again it depends on how many of those rectangles you have, and it will be a function of pi again. All right, so we can leave it at that. It was just quickly to show you how, you know, a cone is also some kind of pyramid. All right, before I get to a tetrahedron, for instance, I would like to go back to a prism, because that's another solid that you are going to be expected to know. All right, so starting from a triangular base prism. If you are looking at a prism, a prism is going to be, you know, all the sides are basically going to be vertical to some base area. Okay, so which means if you are looking at a house, you are talking about looking at the wall from one side, going around the house, and then adding all those surface areas until you come back to where you started. All right, then you have to remember to add the floor area if there's something you have to do, if it is of interest. All right, so triangular base, what we are saying there is that your base area is a triangle. And that would have to be a triangle as well. Now, what you will see here is that there are three surfaces. That one you cannot see, it's at the back. That one you also cannot see, but this one, which is right in front of you, is like looking at the front wall of a house, but you can't see the other ones at the back. So there are three rectangular areas. Now, if I lay this out, I would have three rectangles like that. Plus, at the bottom of that, I could show that there is a triangle. If I started with this line, I would then keep it there as a triangle, let's say, attached to that particular surface. And of course, there is the top one, and I would do the same for that. There you have the top area and the bottom area are triangular. So you've got two triangular surfaces, and to that you're going to add according to the size of that base area. That's the number of areas you're going to add on top of what you added as a base and the top. So you are going to have three more, A, B, C. So then when you do the total surface area total is going to be area 1 plus area 2 plus the other 3, which is area A plus area B plus area C, which are rectangles. So these 3 here are rectangles, these 2 are triangles. Okay, and the triangles in this case come from the name itself, triangular base. All right, so there's nothing difficult from that. From the formulas that I indicated earlier on, you know how to work out the area of a triangle, and you know how to work out the area of a rectangle or a square. All right, so let's move on to the next example. You could have your base as a square. In this case, I must try and have nice drawings here, because I think my drawings are terrible.
They're not that bad.
Yeah?
You can see what they are, so as long as you can see it works.
All right, so that looks like a box, nicely drawn. Okay, so what I've tried to do there is, to show a square at the top and a square at the bottom. So let me just shade my square base area. So again, I said these rectangles on a prism have to be upright. They have to be perpendicular to your base area. So in this case, you've got 4 sides for the base area. Therefore, you will have 4 rectangles all around that prism. Okay. So in this case, if I called this one area 1 and the one, okay, let's say, okay, I think I need to find a way to show these things better. Let's see. Right. So if we have the area at the back as 1, and this area in front as 2, then this one here will be 3, area number 3, and right there at the back you'll have area number 4. Okay, so there's 4 vertical areas. In addition to that, you have the flat areas there, which is the base area and the top area. So the total area therefore becomes area 1 plus area 2, like that, so on and so on. 3 and 4. And these ones are in particular, yeah, they are basically rectangles of the same dimension. Okay, the base and the height will be the same because I said this is a square base. Yes, it's a square base. All right, so then you add your 2 squares, which are the base area and the top area. So that, let's call it area of a square twice. Okay, so that's how you'd get the total surface area of that. And I think we can move to the next one. Before that, let me just see what's next. Yeah, when you come back, we'll do the rectangular base prism, which is more like a square base as well. All right.
All right.
Right.
So, mindsetters, you know the drill. You still need to get on the page, talk to me, let me know what you guys are thinking. And yes, I'm scanning, and I will find the winner. But make sure you stick around because we're going to see you after this ad break. Welcome back, mindsetters. Hope you had a nice little break there. You went and did whatever you had to do. Like I always say, now you need to be focused. You put your bag down, you change out of your uniform. Now you're in front of the TV with your pens and pads and you're ready to make notes. But guys, I'm really wanting to say thank you so much for you guys. Keep posting. Don't worry, if we don't get to your questions during the show, we'll make sure that we answer them on the page. But for now, this will hand over to Iti. Iti, take it away.
Thank you very much. Let me just finish up with the rectangular base, prism. Then maybe we can attend to a few of the questions that our learners have there.
No problem.
All right. So again, if we're talking about a rectangular base prism, how many sides is make up a rectangle? It's made up of 4 sides. Again, you expect that your vertical walls, for the prism, will be 4. There will be 4 of them, and the same way we treated a square, we are going to treat a rectangle. So I will draw it like that because I'm doing 3D in that case. Okay. Let me just show quickly how it's going to look like. This can be solid, solid, solid. Okay. So this is how a rectangular base prism would look like. And let me just show that rectangular base. Now, notice that for a prism, you will always have a side will always have an equal, a side that is another side which is opposite to it with an equal area. Okay, especially if you have got an even number of sides for a square base. In this case, yes, because there is this side, there will therefore have to be the opposite side. So for this side, there will have to be an opposite side. So I'm trying to be careful here because for odd numbered polygons, you are not going to have opposite sides. All right, but for even numbered polygons as the base, you will have opposite sides. So the same way we treated the square, now if we were to lay this out, Let me just get a net of this one. So right at the base, if this was open top, so I would say I'm looking at a rectangular base, and to the side, to the four sides, I would have 4 rectangles, and that rectangle, if it was area A, it would be equal to that area. And the other one, B, would be equal to B. And in the middle, all you have to do is say 2 times A plus 2 times B plus C. Let's say C was the middle one. Oh, well, the base area. And this was open top. Now, that's another thing you must do. You must listen to the question, because either you've got open top, typically like a glass, it's got a closed base, or you just have a, let's say, a cylinder that is empty. That is open on both sides, like your toilet roll,
Oh yeah,
Okay.
definitely.
So it's open on both sides, and therefore you would not be interested in the middle area. Okay, in this case, it's one area because I said it's open top and it's a box. But if it was a closed box, you would have to say plus 2 times C. All right, I think that's what I wanted to emphasize there. So that's the area total would be equal to that. And you know how to find the area of these rectangles. So I think that's what I wanted to cover on this rectangular prisms. Well, finally, maybe I should look at a cylinder. Yes, a cylinder, you could actually think of a regular polygon being a base of a prism. Just like we did with a cone, this time look at the base as a circle, which is just an infinite number of sides, basically. And all you have is all those vertical rectangles adding up to make the curved surface of a cylinder. All right. And in that case, this is what you will see. Okay. And if we were to slit this thing and look at the net of it, it would look like a rectangle. If this was the height of this cylinder, and that was the radius of your cylinder, then you would have 2 circular surfaces. If I can just show them there. 2 circular surfaces plus the cylinder, which it's like when you cut the box right in one corner and lay it out. That's what the net is about. So in this case, take your page, take a flat page, you can actually roll it out into a nice cylinder. So reverse the operation, then you see that that is actually a rectangle. All right, so that rectangle will still have a height of h, and your circle will have the radius of r, and what will be the length of this rectangle now? That's where the challenge is. Yes, because it made up a circle. I think earlier on I indicated that the perimeter of your circle is actually 3 times the diameter, plus that fraction. You remember the pi says 3,14. So you've got about 3, just more than 3 times the diameter of your circle. So in your circle has got a diameter, if it's got radius of r, its diameter is actually 2 times the radius. Therefore, the length will be 2 pi r. So remember, the pi is about 3 times. So 2r is your diameter. So when you say pi times 2r, you are saying pi times diameter. It's like you can lay it out 3 times and make up a full circumference. All right. So that is the length and that is the height. Therefore, you'll know how to find area 1, area 2, and area 3. So this one is length times height. Okay, maybe I should write it down. let me not take it for granted. So the area of a rectangle will be the length, which is 2 pi r, multiplied by the height in this case. So that will be the area of that rectangle. Okay. And for the 2 circles, yes, area will be 2 of them. 1 circle area is just pi times the radius squared. So when you add those two, you got the whole surface area of that cylinder. All right. And can I pick on some of the questions they have? Do they?
I think most of them you actually just covered. So
Yeah?
I'm gonna keep scanning now, and then as soon as I have any, I'll let you know.
Oh, good. All right. I thought there was a question earlier on. All right. So let's move on to another one that I wanted to cover. Is, let's see. You must have heard of a. In fact, I started off with a tetrahedron. I just didn't tell you that that polyhedron, that solid. Remember, I had the name for flat geometric shapes, like the square, the triangle, quadrilateral, all those. We said it's polygons. Now, for solids now, we have a name called polyhedrons. Okay, so the smallest polyhedron that you can form using flat shapes, like triangles, is called a tetrahedron. And I started off with that actually when I started the show. A tetrahedron looks like that. Okay, it's got it's basically a regular triangular base pyramid. All the surfaces are equal. Doesn't matter whether you're at the bottom or any of the sides. So that's what a tetrahedron is. And if you wanted the area of that, obviously I discussed it earlier on, and we came up with three triangles, and I mean 4 triangles actually. In this case, it would be 4 equal triangles. To a cube, that's the next regular solid. It's made up of 4-sided surfaces. Yeah, 4-sided surfaces, and that's a square in this case. So, a cube basically, yes, looks like that. And all the sides are equal. All the sides are equal, and we call this a regular polyhedron as well. And its name, obviously, is a cube. So I'm trying to move slowly to a sphere, basically. I could use very small circles, for instance, build them up in such a way that they match up to form what you call a sphere. And then a sphere is basically another kind of regular polyhedron. And for a sphere, I think at your grade, they will be giving you a formula if they want you to find the surface area of a sphere. Well, I can tell you what it is. If you had a sphere, the surface area would actually be 4 pi r squared. But it's not important for you to know this now. All right. Now, another thing I wanted to work on, remember I distinguished between simple areas and compound areas. I would like to take different shapes and try and build compound areas out of that. Things like combining a rectangle and a triangle, or a circle, or half a circle, those kind of things. And that's what you'll come across in most of your tests. All right, so let's just venture into that and investigate this. If I had a triangle, or let's say we had an area that looks like that. and I say to you, this is point A, B, C, D, E, F, G. And I say to you, find the surface area of this. Of course, you'll have to say to me, give me a few measurements. I can't start the way it is, but I can see shapes already. I can see shapes already in the sense that that part, if I'm to shade the area that I want you to work out, let me just do that. So now what's going to happen here is if I want that shaded area, I will have to perceive that there is a bigger area that I could have formed, and that would have been a rectangle. So what I would have to measure, therefore, is that breadth, let's say, and that length. Then you will say, yeah, but now suddenly you have included areas that were not asked for. Yes, I have, therefore I have to exclude them. And let me take that pen. And that area, you'll say to me, well, what's the radius? Because I can see it's basically half the area of a circle, what you call a semicircle. Then I'll have to go and give you that measurement and say that is R. If I give you that as R, you're just going to say, okay, area of a semicircle is half. I know the area of a circle is pi r squared. So that semicircle is definitely going to be half of that. And by the way, I needed to write that area of a bigger rectangle. Area of the rectangle, the bigger one, was simply length times breadth. So I would have to give you that kind of information for you to be able to work out the shaded area. Now, suddenly you realize there is another area which I included, which you protest that I should not have included. I need to therefore subtract that. But I will have to give you measurements, about that. So if I say to you, this is B, and this is, let's say, X units, and the other one I can give you is maybe just measure from A to G, and A to G, let's say, is Y. Okay, just from there to there. That's good enough because now you can basically tell me what is from A to B. So you can tell me what is the base of that triangle. It's going to be, the whole length is L, remember? So all I have to do is say that dimension is the whole length, take away Y. Okay, so you cannot complain about that triangle. You've got good enough information. Now you can say half of base times height. So in this case, you can take, let's see, you can take X as the base and L minus Y as the height. So let me just write that as well. Area of a triangle is equal to half your base, let's say you said X, and your height would be L minus Y, L minus Y. Okay, so now you know what to do with that. The total area that we are interested in will be area of the big rectangle, take away area of a triangle, take away area of the semicircle. That's typically what they can ask you, compound areas.
All right.
Right.
Wow,
I think we've come to the end of the show. Right?
Yeah, that went quick. On that note, mindsetters, I'm checking the page, but for now, this is where I sign off and say see you next time. Liberty, thank you very much for sponsoring. Cheers.